Sky Leviathans, echoes in the radar for decades. Pilots have reported something they were never trained to identify. Not turbulence. Not birds. Not drones. Shapes. Massive, translucent shapes drifting through the upper atmosphere, visible only for seconds before dissolving into cloud banks. Shapes that moved against prevailing winds. Shapes that pulsed faintly with internal light before vanishing into vapor. Most reports were dismissed. Optical illusions. Ice crystal refraction. Instrument interference. But in 2026, the data began to change. And this time, the sky answered back. Echoes in the radar. In early 2026, a network of high-resolution meteorological satellites and ground-based Doppler radar arrays began detecting non-metallic returns at altitudes between 9 and 18 kilometers, well into the upper troposphere and lower stratosphere. These returns were not consistent with aircraft. They emitted no transponder signals. They produced no heat signatures typical of engines. They reflected radar waves weakly, like mist, but held coherent shapes. More unsettling, they moved with intent. Instead of dispersing like vapor under wind shear, the anomalies maintained formation. Clusters elongated, compressed, then reformed. Some rotated slowly, as if pivoting around invisible axes. Meteorologists initially flagged them as phantom clusters, a known radar phenomenon caused by temperature inversions or signal scattering. But phantom clusters don't hold shape for 47 minutes. They don't ascend against jet stream flow. And they don't glow. The bioluminescent nights, the first confirmed visual anomaly, came from a long-haul cargo pilot crossing the Pacific at 11,000 meters. The crew reported a faint green luminescent mass drifting several kilometers off their port side. It was not lightning. Not aurora. Not electrical discharge. It pulsed. Softly. Like deep-sea bioluminescence. Within weeks, atmospheric researchers began cross-referencing pilot sightings with satellite photometric data. Sure enough, high-altitude low-intensity light emissions were recorded in cloud layers previously considered optically inactive. The wavelengths matched bioluminescent spectra found in oceanic organisms, particularly gelatinous plankton and siphonophores. The implication was impossible. Bioluminescence in the stratosphere? The gelatinous hypothesis life on Earth has repeatedly surprised us. We once believed the deep ocean trenches were sterile. Then we found ecosystems thriving around hydrothermal vents. We believed clouds were chemically hostile, too cold, too irradiated, too unstable for life. But what if life adapted differently? The gelatinous hypothesis suggests the existence of ultra-low-density organisms composed of lightweight, semi-transparent membranes filled with lighter-than-air gases, possibly hydrogen or methane produced biologically. These entities would not fly in the traditional sense. They would float, buoyed by internal gas sacs, drifting within cloud strata where humidity and temperature gradients offer structural support. Their bodies would need to be enormous. Kilometers across, perhaps. But incredibly thin, like colossal atmospheric jellyfish. Their tissue density would approach that of air itself, rendering them nearly invisible except under certain light conditions. Radar would struggle to define them clearly. Unless they moved. Formation behavior. One of the most compelling pieces of 2026 data came from a decentralized atmospheric sensor grid over the South Atlantic. For 3 hours and 12 minutes, radar and lidar systems tracked 3 separate anomalies maintaining triangular formation despite 120 km/h crosswinds. Weather balloons released into the same altitude band drifted rapidly east. The anomalies drifted north, then south, then stabilized. This behavior contradicts passive atmospheric motion. It suggests internal propulsion, or controlled buoyancy. Perhaps microelectrical discharges adjusting ionization layers around them. Perhaps internal muscular contractions altering gas distribution. Whatever the mechanism, the movement appeared coordinated, not chaotic. The historical record long before radar, there were stories. World War II pilots described sky manta rays. 1960s commercial aviators reported transparent blimps without engines. High-altitude reconnaissance crews in the 1980s logged non-solid visual masses. Most accounts were buried under classifications of fatigue-induced hallucination or atmospheric distortion. But when modern data overlays those old flight paths, something curious emerges. Clusters of sightings correlate with regions where 2026 radar anomalies are now being detected. The Pacific Convergence Zones, equatorial storm corridors, high-altitude humidity corridors near the Andes. It is as if these regions serve as migration paths or feeding grounds. A biological frontier. If such organisms exist, what would they eat? The stratosphere contains organic particulates, microbial spores, and atmospheric carbon compounds. Some scientists theorize they could metabolize airborne microorganisms or harness electrical energy from lightning activity. Cloud systems generate enormous electrostatic fields. Perhaps these leviathans feed on energy itself. Perhaps lightning is not merely atmospheric discharge, but part of a larger ecological cycle we have yet to recognize. Their translucent forms would allow sunlight to pass through, minimizing visual detection from below. Their altitude would protect them from terrestrial predators. They would be invisible to most observation systems. Hidden in plain sight. The glitch debate skeptics remain firm. They argue radar anomalies can be amplified by humidity layers. That bioluminescent readings may be misinterpreted satellite noise. That formation behavior could result from complex wind shear modeling errors. And yet, independent sensor arrays across 3 continents have recorded similar signatures. Mechanical glitch explanations falter when patterns repeat across decentralized systems. Data noise does not coordinate. Glitches do not migrate seasonally. The transition point. Perhaps the most pivotal moment occurred when a high-altitude research drone equipped with hyperspectral imaging briefly intersected one anomaly. The footage lasted only 14 seconds before signal loss. But within those seconds, something extraordinary appeared. A vast, semi-transparent structure with faint internal filament patterns, like veins, extending across an enormous curved surface. It shimmered. Then it faded into cloud. Signal lost. Drone recovered days later, electronics partially fused, possibly by electrical discharge. No definitive proof. But no easy dismissal. What if the sky is alive? For centuries, humanity believed the ocean depths were the final frontier on Earth. Now, perhaps, it is the sky. An ecosystem layered above us, evolving in thin air, untethered from soil, from ocean floor, from gravity as we understand it. Creatures so large they stretch across cloud banks. So light they leave no footprint. So rare that only chance encounters reveal them. If confirmed, Sky Leviathans would redefine biology itself. Life would not be confined to land or sea. It would float, hover, drift silently over cities, mountains, oceans, unseen by billions below. The quiet above tonight, when you look up at a sky heavy with clouds, consider this. Somewhere beyond your sightline, beyond commercial flight corridors and weather forecasts, something may be moving. Not storm. Not aircraft. But something vast and gelatinous, pulsing faintly with internal light. Watching. Drifting. Existing. And we are only beginning to listen to the echoes in the radar. Please like, subscribe and follow for more.